Last video, we showed how AI agents can remember users across sessions. In this video, we take a deep dive. Before anything runs, MemoryBank depends on your Google Cloud environment being correctly configured. You need two APIs enabled, Vertex AI and Agent Platform. And more importantly, your service account needs explicit memory permissions: generate, retrieve, and update. This is what defines who can read and write long-term memory in your system. At the core of the system is MemoryBankConfig. This defines how memory is created, stored, retrieved, and expired. There are four main components. Customization controls what gets remembered. Generation defines how conversations are turned into memory. Similarity search enables retrieval using embeddings. And TTL controls how long memory lives. This is what that configuration looks like in code. Customization config defines the topics, both managed and domain-specific. TTL settings control lifecycle, separating newly created and updated memory. Generation uses Gemini to extract structured facts, and the embedding model enables vector-based retrieval. This block is effectively your memory system blueprint. Zooming into the most important part, memory extraction. MemoryBank doesn't store raw chat. It extracts structured signals. Managed topics cover common categories like preferences and instructions. Custom topics let you define domain-specific memory, like dietary constraints or travel rules. This is what determines what actually becomes long-term memory. Once configured, this blueprint is deployed into a managed runtime using Agent Engine. This step provisions the actual infrastructure: storage, vector index, and background extraction pipeline. This is where MemoryBank becomes a running system. This is the deployment step. You pass your MemoryBank config into agentengines.create, and this returns a resource name, your engine ID. This ID is critical. It's how your runtime connects to the memory system. Now we move to runtime, how memory is actually used during execution. Every time a user sends a message, memory retrieval happens first. PreloadMemoryTool searches for relevant memory using embeddings. That memory is injected into the model's context. The agent generates a response, and after the session ends, memory is extracted and saved asynchronously. This creates a continuous memory loop. This is how you wire that loop into your agent. Vertex AI Memory Bank service connects your agent to the memory system. PreloadMemoryTool handles retrieval before each response. And the callback function saves the session back into memory. This completes the full read-write cycle. Finally, security. Long-term memory introduces a new attack surface: memory poisoning. To prevent this, Vertex AI uses Model Armor. It inspects input before processing, filters stored memory before retrieval, and validates outputs before returning responses. Combined with strict user-level isolation, this ensures memory remains safe and private.